Now we're going to look at parabolas that do not have their vertex at 0, 0. So we have transformed them or moved them. And it's all going to be based on where the h and k is now. So the new vertex is at what we call h and k. So we've moved it off of 0, 0. That's your vertex. So if you think about where the focus would have to be, the focus has to be inside the parabola, so it'll be about right there. And then the directrix has to be on the other side of the vertex, outside the parabola, the same distance away as the focus was from the vertex. And so that distance, if you recall, is called c, the distance between the focus and the vertex. That distance between there is called c. And so if you notice, what you're adding c to is the y value of the point. So whatever the focus, whatever the vertex was, hk, you're going to add the c to the y value, or the k value in this case, because you're changing the direction upward, but you're not changing the sideways movement at all. So the x value will remain the same, but the y value will change by a value of c. So you're going to add c to the k part of the vertex. Then, to get to the directrix, which is below the vertex there, you're going to subtract an amount of c from the vertex. And so that is going to be the horizontal line, y equals, is going to happen at exactly whatever the k value was, or the y value of the vertex, minus the c amount, that is that distance between the vertex and the directrix. So that is where these formulas come from. So it's better to create them rather than memorize them. Just kind of logically think about, what is the distance c? It's the distance between the vertex and the focus, and in which direction am I doing that c? And you either add it or subtract it. And you add it always to the focus, and you subtract it always to the directrix. Same if it's going sideways. So this, let's say, is a opening right parabola, so a is positive. That puts the focus inside the parabola to the side of it, and it puts the directrix back here as a vertical line. So the directrix changed to an x equals instead of a y equals, because it is now a vertical line instead of a horizontal line. And if you think about the vertex being at hk again, wherever that may be, to get to the focus, you're going to move to the right or to the left sometimes if the parabola was going the other direction, but you're moving sideways. So that affects the x value of your vertex. You're going to add c to the x value of your vertex. And then your y value of your vertex is going to stay the same, because you didn't move up and down any when you went from vertex to focus, you only moved sideways. So the x value changes, but the y value does not, so it stays k. And then you move in the opposite direction to get to the directrix. So wherever the vertex was in its x value, which is h, you're going to subtract c, an amount of c, and that's where you're going to land for your directrix. And it's a vertical line, and it's going to be wherever h was minus the value of c, and that's where the directrix is going to land. So that's where these formulas come from. And again, don't think of them as formulas to memorize. Just kind of picture where these things are going to be, and did it move sideways or did it move up and down? And then that will help you know, do I add the c to the y value, or do I add the c to the x value? And then always subtract it for the directrix. So with just giving us an equation, they could ask, what is the vertex, focus, directrix, axis of symmetry of this parabola? And they may not even be asking you to graph it. They may just want to know those pieces of information. But I always sketch the graph just to get a visual on what's going on, because the way I remember this is not by memorizing a bunch of formulas with h's and c's and k's and all that stuff, but instead I create it on a graph, and then it helps me to know what direction everything is going. And so first of all, if you want to use the H and K formula, you need to get the positive 4 over to the other side. So we're going to subtract it on both sides, and that way it puts it in that K position, and then we have equals X minus the H squared. So now it looks a little more like the formula that we've been using. And so the H is always the one next to the X. And so we're going to use 2 for our H. And the K is always next to the Y. And so we're going to use 4 there. Notice that the way it looks in the equation sign-wise and the way it looks as the vertex is always the opposite. So if you see minus 2, you're going to put a positive 2 in here. If you see minus 4, there's going to be a positive 4 here. And that's because the formula itself already had minuses in it, the standard form of a parabola. And so after that, then we can figure out what the focus is. The focus has the letter C in the word focus. And so I remember that focus goes with C, and C always is the formula 1 over 4A. And so I am going to put in the A, and A is whatever is in front of the squared term, so in front of the x minus 2 squared, and that is an understood 1 because there's nothing written there, so we're going to say that A is 1. And that makes C 1/4, and so what we do with that C is we add it to either the H or the K. Now this is where the picture comes in handy without having to memorize a formula. So a couple of things we know about this parabola is because the y is not squared, but the x is being squared, this is an up-down type parabola. Since A is a positive 1, we know it's going up, not down, and we know its vertex is at 2, 4. So if we just kind of sketch a 2, 4 vertex in this parabola going upward, that will tell us a lot of things about where the focus and directrix should be located. So since you know the focus has to be inside the parabola and the directrix has to be outside the parabola, they would look like that. And therefore, what is changing from the vertex to the focus is it's moving up, and so that is a y value change, not an x value change. And so the x value will stay exactly the same, but the y value will increase by an amount of c, because the distance between the focus and the vertex is c. And so we are going to add 1/4 to the k, and that's where the k plus c comes into the formula. So we're going to add it to the y value, or the k in this case, and it's 4 and 1/4, so I'm just going to put 4.25. I don't like mixed numbers. And then for the directrix, it's going to be a distance of 1/4 below the, like another horizontal line could be at y equals 4, and it's going to be 1/4 below that, so this would be y equals 3.75. That's where that line is, because this is even with the number 4 on the y-axis, so if we go 1/4 below that, we'll be at 3.75. So y equals, and what that was it was a k minus a c, and that's where the 3.75 can come from as well. And then the axis of symmetry, we can just draw and think about where that is. That is a vertical line, which means it's x equals, and it's going right through the value 2 on the x-axis, so that is x equals 2. So the drawing helped us to get these other values without having to think so hard about memorizing a formula. Another way they could ask a similar question is, what if they give you the vertex and focus and tell you to write the equation of the parabola? Again, they may not be asking you to graph it, but I always sketch a graph to kind of get a visual on where this thing is going. So first of all, let's graph these 2 points. And just graphing those 2 points immediately tells us what direction this parabola is going to go, because it has to go through the vertex but open in the direction of the focus. So it's going to be something like that, which will also tell us about where the directrix needs to go and where the axis of symmetry needs to go. So let's put those values in and also figure out what our A and our C are. They may or may not be asking for this, but you can see that the axis of symmetry is a horizontal line, so y equals, and it's going right through the 7. And then the directrix is going to be a distance of, however far the distance is here, it's going to be the same distance the other direction. So you can tell from where we graphed at 3 and 5, that the distance between the vertex and the focus is 2 units. So we want to go 2 units backwards, and that puts us more here, I guess, which is at 1, because that's 2 before 3. So what we want to do is call this x equals 1. So I just did 3 minus 2. So that's our directrix. So since the distance between the focus and the vertex is a distance of 2, we know that C is 2. That's our focal length. And therefore we can use A equals 1 over 4C to help us find A. And so A is 1/8. And if you ever get messed up on your signs, just remember that, kind of look at the picture again, and if the parabola is opening to the right, it must be a positive A. So if it's opening to the left, you should get a negative A, you can usually just tell by the direction it's opening whether you should use a positive or negative. And then what we have then is y, rather it's the sideways parabola, so the x should be first, and then the y should be the thing that's going to end up being squared because it's a sideways parabola. And so then we have h should be here. This is your h and k, so it's always x minus the h and y minus the k, and then the a is your 1/8. And so here is the equation. Sometimes you will see the 3 move to the other side, and if so, it would look like this. So that's a possible way to write it as well. Sometimes we're given an equation in standard form and we need to get it in vertex form so that we can do all the things that we've been doing in these other slides. And so we need to be reminded of a method called completing the square. That will get you the perfect square binomial you need right here. And this is the method that you do. First, we want to get the constant off of this side. Then we make these 2 blanks on either side of the equation, and that's where we're going to complete the square. So here are the 2 things you need to do to complete the square. You take the coefficient in front of the x and you half it, and you get -3. That -3 will actually go here with an x. And then after you do that, you square the -3 and get 9, and that will go in your blanks. So just kind of review that and get used to that idea. The reason this works is because if you factored this, you would get x minus 3, and therefore it's 2 of the same, and that's x minus 3 squared. So just remember, the shortcut is that it will always go there, and this will always go there and balanced out on the other side as well. So then what you have over here is y minus 2, and now we have it in our vertex form where our a is 1. And we can see our vertex would be 3, 2 from the h and the k.